Hello everyone, and welcome to the video on properties of logs. We spent the last two videos talking about exponential functions and log functions, and one of the things that you should have noticed on there and we've talked about is the fact that exponential functions and log functions are inverses of each other. So that will come into play a little bit with the properties that we have today as well. So our skill objectives for today. Number one, we want to write a single logarithm as a sum or difference of logs. Number two, write a logarithmic expression as a single logarithm. And third thing is evaluate logarithms of a general base. Our conceptual objectives is to derive the 7 basic logarithmic properties. Honestly, we're going to probably spend that time in class. We'll talk about the proofs for the properties. In this video, we're going to focus on the application of these log properties. And the second one is to derive the change of base formula. Again, we'll talk about that in class on next time we meet. Because the answer to a log problem is an exponent, one of the things I want to do is make sure we spend some time and review some of the properties of exponents. One of the things that always happens when I look at this, I watch, is that a lot of times people, when they look at these log properties or these properties of exponents, they start really overthinking the expressions and what they're working with. Keep in mind, I know that you know how to work with exponents. These are just the formal application of the things that you have done. Now, the other thing you have to keep in mind, and in some cases there are some mistakes here that do happen, but you can always look at these to go and make sure what you did is correct. Okay? So, in this case, the first exponent rule, when I take a b to the m times b to the n, I get b to the m plus n. In other words, when I multiply two things with the same base, I add the exponents. Number two, b to the negative m power is equal to 1 over b to the m power, the positive m. So when I see a negative exponent, I know I'm going to be going through and taking a reciprocal in some way. Now, third one, b to the m over b to the n is going to be simplified to b to the m minus n. Notice it's the top exponent minus the bottom exponent. And this is what happens when you simplify it. This is what happens when you reduce the fraction. Okay, you are actually subtracting exponents when you reduce fractions. B to the m raised to the n power is going to be b to the product of m and n. So when I have a power to a power, I multiply the exponents. And here, this is probably, number 5 is probably the most, it leads to the most problems that people have. In this situation here, notice I am taking a times b to the m power, and I am allowed to distribute the exponent there. I'm only allowed to do that because I'm multiplying these two things. If there was an addition or subtraction, I could not distribute that exponent. And we see that a lot. There's a lot of times people will make that mistake. So please be careful of that. This only applies when you are multiplying the two things that are inside the parenthesis. The other one are ones we've talked about and should be pretty comfortable with at this point. B to the 0 is equal to 1. So if I take a real number, raise it to the 0 power, I'm going to get 1. And b to the first is just b. Those are exponent properties that you are familiar with these, and I just wanted to review these with you. They will have some bearing on what happens to the logs because we all know a log, the answer to a log problem is an exponent. Before we go on, let's take a look at a couple of examples that we have. Here in the first one, I'm taking 2 to the 6th times 2 to the 4th. Again, because I'm multiplying two things with the same base, that's going to be 2 to the 6th plus 4, or 2 to the 10th power. 3 to the 5th divided by 3 to the 2nd. Dividing two things with the same base, I subtract the exponent, so I get 3 to the 5 minus 2, which is 3 to the 3rd. 5 to the 4th over 5 to the 7th. Again, I subtract the exponents. So that's going to give me 5 to the 4 minus 7, which is 5 to the negative 3, which by the second property we had was 1 over 5 to the 3rd. And the last one, 6 to the 3rd raised to the 8th power. Power to a power, we multiply the exponents. So that's going to be 6 to the 24th power. Now let's look at the properties of logs. We're going to have b m, n are going to be positive real numbers, where b does not equal 0, that is a b, and p and x are going to be just any real numbers. Then the following properties are going to be true. Number 1, log base b of 1 equals 0. We've talked about that. You take the log of 1, anytime you take the log of 1 is 0, because what that is saying when we solved these before, if I said b log base b of 1 equals x, that would mean b to the x equals 1. And the only power that I can raise a positive number to get 1 is 0. So in that case, when I take the log of 1, it is always equal to 0. Log base b of b, when these two numbers are the same, it's just going to be 1. Number 3 is kind of an extension of number 2. Again, when the two bases are the same, you get x. And here, the same thing. These two bases there, you also get x. These 3 and 4 also come from the fact that logs and exponentials are inverses of each other. And because of that, when I do a composition of a function and its inverse, I know I'm going to get just what's in the exponent. I'll just get x. So here I'm taking a composition of the log and its inverse exponential, and here the exponential and the inverse of the exponential, which is the log. So both of these, what you're looking at is a composition of a function and its inverse, and that is always equal to x. Properties 5, 6, and 7 are going to be the ones that a lot of what we do is going to be focused with those. When I take the log base b of m times n, that is equal to the log base b of m plus the log base b of n. In other words, when I take the log of a product, it's equal to the sum of the individual logs. Number 6, this one should make a little bit of sense when you recognize the inverse operations that we have. In number 5, we did multiplication, and that resulted in addition. The inverse, the opposite of multiplication, is division. So log base b of m over n, it should be no surprise then, is going to be log base b of m minus log base b of n. In other words, when I divide, when I have a log of a division, it's going to be the difference of the logs. Also notice here that it is the log base b of the numerator minus log base b of the denominator. And the last one, log base b of m to the p power. That p is an exponent. That exponent is allowed, it can be brought down in front, so that's going to be p times the log base b of m. Again, also, please note that the last 3, 5, 6, and 7, properties 5, 6, and 7, are in a different color because those really are going to be used in a slightly different way than the first 4. So we'll talk about that once we get to the breaking down and combining of logarithmic expressions. But to start out with now, let's just take a look at some examples involving the first 4. In this case, in the first example, I have log base 4 of 1. Well, really, anytime I see a log, doesn't matter what the base is, when I see a log of 1, automatically that is 0. I know it's going to be 0. Same thing here. When I see a log of base 8 of 8, anytime this base matches exactly the number that's inside of the log, that is always going to be 1. So I know those from properties 1 and 2. The inverse property. 12, log base 12 of 12 to the x. When the bases are the same, the only thing left is going to be the exponent. And same thing here. When the bases are the same, the answer is going to be what's inside that log. Now this number 3, most people are pretty comfortable with. It's number 4 that a lot of people will forget, but again, it is the inverse relationship. So make sure you note that in terms of properties. Let's look at another one here with number 5. Log base 7 of 7 to the x plus 5 minus 2 equals 0. In this case, we want to solve it for x. Well, because I know that because these two are the same, I can first I went through and added 2 to both sides. So I have log base 7 of 7 to the x plus 5 equals 2. But because my bases are the same, the answer is just going to be the exponent. That is property 3 up there. And so I get that log base 7 of 7 to the x plus 5 is just x plus 5. So I know x plus 5 equals 2. And therefore I can say that x equals negative 3 by subtracting 5 from both sides. Now let's get to properties 5, 6, and 7. Number 5 was this first one up here. Log base b of m times n is log base b of m plus log base b of n. Log base b of m over n is log base b of m minus log base b of n, and log base b of m to the p is equal to p times log base b of m. Now these properties are going to be used to break up or combine logarithmic expressions. So in other words, what that means is not only are you going to have to go use these properties going from left to right, but you're also going to have to go from right to left. And I want you to notice here, now the first one and the third one, generally people don't have much of a problem with. They go through and they say, oh, log base, especially when we're going from right to left. That's where issues usually come. Because they look at this, they say, oh, that's just going to be the log of the product. Where problems come in is with this second one. When I go from right to left, so I'm going from log base b of m minus log base b of n, people recognize that it's going to be a fraction. But I want you to notice here that the log is out in front of the fraction. It's not in the numerator. It's not in the denominator. It is in front of the fraction. The fraction is inside of that log function. That is where people make the most mistakes when combining these. Often when I see this, I'll see a problem. It will say log base b of m over log base b of n. Please note, that won't ever happen. When you go through with this, you'll have a single log out in front of the fraction. So make sure you keep that in mind when you're working with these properties. There are going to be two types of problems that you have with this. One is going to be to write, the first one is going to be to write as an expression, logarithmic expression, as a sum or difference of logarithms. So in this first one, what I have is the natural log of x squared over y. Well, because I'm taking a division here, x squared divided by y, I know by property 6 that that's going to be the natural log of x squared minus the natural log of y. And then by property 7, that x squared, the natural log of x squared, I can bring that exponent out in front, so that's going to be 2 times the natural log of x minus the natural log of y. And there's nothing else I can do to simplify that. Number 2, log of x squared times y cubed. In this case, it's a product, so by property 5, I know that that's going to be the log of x squared plus the log of y cubed. And that's going to equal, by property 7, I can bring these exponents out in front, so that's going to equal 2 times the log of x plus 3 times the log of y. In the third one, okay, now we're going to look at a little bit more complicated expression. This is log base 6 of x plus 2 times the square root of x minus 3. Well, again, because we're dealing with a product here of x plus 2 and then that square root, I know that's going to be log base 6 of x plus 2 plus log base 6 of x minus 3 to the 1/2 power. Remember, square root would be to the 1/2. And that is going to equal, by property 7, log base 6 of x plus 2 plus 1/2 times log base 6 of x minus 3. Take a look at these, make sure you're comfortable with the application of these log properties, and then once you feel comfortable, you can move on to the next slide, which will look at the other types of problems we're going to have to deal with. Now let's take a look at the other type of problem you're going to have with these expressions. We're going to have to write each expression as a single log. In other words, we have to combine multiple logs using these log properties so I have a single log at the end. So let's start out with the first one. I have 2 times the natural log of x plus 4 times the natural log of y. Now the one thing you have to remember on this, use order of operations when combining log expressions here. So when you're working on these things, if you're trying to decide, do you deal with the 2 and the 4 first, or do you deal with that addition first, use order of operations. We do multiplication before we do addition. So I'll deal with these 2 and the 4 as exponents before I'll deal with the addition. So in this case, it's the natural log of, it's going to be 2 natural log of x plus 4 natural log of y. That 2 and the 4 become exponents. So that will become the natural log of x squared plus the natural log of y to the 4th. Now, by property 5, I know that when I'm adding 2 logs, that's going to be the log of a product. So that's going to be the natural log of x squared y to the 4th. Number 2. The common log, we'll look at it with the common log here, but this works for any, as same thing with number 1, that works with any base. The log of x minus 3 log of y. Again, because I'm dealing with, I do order of operations, I'll deal with that 3 first. That 3 becomes the exponent on the y, so that will equal the log of x minus the log of y to the third. Now this is where people make the mistake. When we go and combine these things, the log, because I'm subtracting logs, that is going to be the log of a quotient, of a division. So it's going to be the log of x over y cubed. Notice a single log in front of the fraction. So I get the log of x over y to the third power. Now let's look at a little bit more difficult one. We're going to have a few things going on here. We have log base 4 of x minus 2 plus log base 4 of x plus 2 minus 3 log base 4 of x squared minus 4. Now this one, there's a lot of different ways, but I generally go through and deal with that multiplication first. So I'll bring that on as an exponent to move the 3, that 3 up as an exponent there. So I now have log base 4 of x minus 2 plus log base 4 of x plus 2 minus log base 4 of x squared minus 4 to the third power. That will equal. Now, what I want to do is I'm going to go through on this now and combine these things. But what you have to remember on this, when you do these things, also when you're combining, always remember order of operations. And one thing that people tend to forget is that order of operations do say to go from left to right. So the first two that I'm going to combine, because they're the ones furthest to the left, are going to be log base 4 of x minus 2 and log base 4 of x plus 2. By property 5, I know that's going to be log base 4 of x minus 2 times x plus 2 minus what we still had, the log base 4 of x squared minus 4, that to the third power. Now, I can simplify this. X minus 2 times x plus 2, that is a difference of 2 squares. So if I multiply that out, I will get x squared minus 4. So log base 4 of x minus 2 times x plus 2 is just going to be log base 4 of x squared minus 4 minus log base 4 of x squared minus 4 to the third power. Well, by property 6, I'm subtracting. So that's going to be log base 4 of x squared minus 4 over x squared minus 4 to the third. I can then reduce that, and I'll get log base 4 of 1 over x squared minus 4. Now this one, because it happened to work out this way because of how the problem was written, but we could have, in this case, it would have been okay if we had not gone and moved that 3 up there as an exponent. But my general feeling is always go through, move that up as an exponent, and then reduce the fraction afterwards. So again, what you want to do, pause the video, make sure you're comfortable with each one of these problems in terms of how it was worked out, and make sure to ask in class on next time if there is something that you're not sure about. The last thing we have to deal with is what is called the change of base formula. Now, this one is one that you are familiar with. Some of you have already asked me about this earlier in terms of evaluating log property problems that we've seen in 3.2. But what we have here, for any log bases a and b, and a positive number m, the log base b of m is equal to log base a of m over log base a of b. This allows us to write any log using any base we want to choose. Now the common ones are going to be common log base 10, natural log base e, but we can use whatever base we choose. So if you wanted to use base square root of 5, you could do it. So I know from this that the log base b of m, probably the two most common, is going to be the log of m over the log of b, or the natural log of m over the natural log of b. Where the change of base helps us is if we're trying to find the log base 7 of 34, or something along those lines, where what we're trying to take the log of is not a nice power of the base. So in this case, prior to the change of base, this would not have been possible for us to do with really much accuracy unless we happen to have a slide rule and we were comfortable with it, which most of us are probably not very comfortable with. The other thing that you have is with the change of base, though, we are able to do this because we're able to transfer this, take this problem and put it into a form that your calculator can work with. Now, some of you are saying, well, wait a second. Last year, when we did logs, there was a place where there was a command where I was able to go through and put whatever base I wanted to there. That is true. That is true on your calculator. Some of you in the older TIs, the TI-83s and the older TI-84s, you don't have that as an option. The newer TIs, 84s do. But really what that is a wizard that those calculators use to go and then plug it and do the calculation in the change of base formula. So on these ones, while some of you might know where it's at and be able and have that, I really need you to focus on using the change of base formula and writing it in that way, because that is what's actually going to be, in general, the most helpful thing for you moving forward. So with the change of base, I know log base 7 of 34 is log of 34 over log of 7, or I can think of it as the log base 7 of 34 is the natural log of 34 over the natural log of 7. And once we have it in that form, I can now put this in either one into my calculator. And when I do that, I am going to find out that the log base 7 of 34, that it is about equal to 1.8122. You can get that by putting it into your calculator. Also, remember when you put it into your calculator, make sure to close off the parentheses. Your log problems, your log command keys will put an initial parenthesis there. If you don't close it off, it will cause problems, and that could give you the wrong answer as well. This now concludes our video on the log properties. Again, like I mentioned before, we will spend time in class going through and talking about the proofs for these properties. They don't take that long to do. They're relatively easy proofs. If you'd like, you can take a look at them in your book. At least the proofs for properties 1, 2, 3, and 4 are on page 376. And the proof for property 5, which really can be used as a model for the proofs of properties 6 and 7, are on page 377. So if you want, you can spend some time taking a look at that. Otherwise, we'll talk about those in class, and then we'll move forward from there in terms of working with the log properties. We will also do a couple more problems similar to what we did earlier in terms of working with properties 5, 6, and 7. But otherwise with that, I will see you in our next class.